Good morning all. Today I wanted to show you a new board I've developed, an 8-bit development board to replace my old 8-bit development board, which used the old Atmega 328p. Now basically what I wanted, I didn't want a more bigger or faster or more powerful chip. I just wanted the same 8-bit architecture so I can use the same software. I didn't need to add new libraries and such, so it's just 100% compatible, but I needed more SRAM, programming RAM and flash and EEPROM, because as good as this chip is, you run out of programming space really fast. So I decided to design a new one and gave it some extra features. Now the main feature, the main update obviously, is the MCU, which now uses a Atmega 1284p chip, which has 128K of flash memory, which is great, 16K of SRAM, which is really great, 4K of internal EEPROM, and yeah, that's quite a lot better than the old board. So this particular board, the way I designed it, it has 8 analog input and outputs, 28 digital pins, which 8 of them are PMW enabled. So yeah, a lot of options. Now you can see it's slightly bigger, but there's a reason for it. So let me show you the features first. So the main difference is I used a NeoPixel or a WS1228p chip instead of the standard LED on pin 13. And the reason why I did it is because I wanted to use its colors to debug stuff. Normally when I debug, I use an external LED or I use the LED on pin 13, but that's only limited, it can only go on and off. And now I can use different colors for different errors or messages. And I do that a lot because my old board did not have a serial output. So the only way I could debug stuff was with the LED, and it was very limited. And having a NeoPixel on board is just cool. The other extra feature, reset button, obviously. USB-C, so now I can actually reverse the connection instead of getting it right the third time, which is great. Also on the back, it has a micro SD card reader. Now I really wanted a micro SD card reader because I use it a lot for my products and projects. And that's actually what determined the width, by the way. That's why it's slightly wider, but it's designed for breadboard. That's why it has no mounting holes. I made it as small as possible, but it is breadboard only. Although you can use it in any project. You don't have to use it on a breadboard, obviously. But since I designed it for myself, it's breadboard friendly. It also allows for multiple power sources to be used. And let's talk about it, because that's a very important part of this project. I usually work with stuff like this, like big NeoPixel displays. Now this is a 7-segment display I've designed many years ago. And the problem it has, it draws a lot of current, a ton of current. So you need to power your project externally, well, which is great, no problem at all. But then when you program it, you have to make sure you disconnect the LEDs, you disconnect the external power source before you start programming it, because, well, the USB port cannot draw 9 to 8 amps some of these displays require. So it's very easy to just forget about it, leave your Pixels connector, plug in your USB and blow up stuff. So one of the main things I wanted to make sure of is that it was able to use external power, which it is, and USB at the same time. But if both of them are connected, it would prefer the external power, but still leave the serial communication intact. In other words, I can leave it plugged in, I can flash it as many times if I like, and still power it externally. And then if I switch off the external power, it will switch back to either USB or ISP power, depending which one you will use to program. Now, if you want to use the bootloader, you can use the serial port. If you're like me, don't like the bootloader because it introduces a small boot up delay, you can just program it directly. And I use this little Arduino board I've created, which basically just runs the Arduino ISP sketch, and it allows me to flash it directly. And the only difference in the IDE is you hold the shift key when you hit program instead of just click program. So there's really not a lot of difference, but you get a little bit of extra programming space, and more importantly, there is no startup delay because there's no bootloader. But again, you can do whatever you want. So for now, I've used the bootloader. Something else, yes, it uses a serial communication chip, the CP2104, and factory default, it's not quite the way I wanted it. Now it has 2 GPIO pins, but they're off per default, so you actually have to program this chip to make it able to use those GPIO pins to toggle, transmit and receive. So I've connected 2 LEDs to it, but initially they didn't work because you have to program it. That's a pain in the ass. But on the downside, if you program it, and it's a one-time programming only, you can actually put in your own manufacturing data. And that's cool. So this board will not actually show up as my DP 1284p Pro or my Dark Photons 1284p Pro board on the computer. So that's kind of cool. Now let me show you what it can do. Let me give you a quick demonstration. Let's plug it in. And the first thing you see is those flashes. So I actually tested the NeoPixels if they work. And I've connected an external screen. Now this is cool. This is one of the features I really wanted. Most of these screens are 3.3 volt only. So that means you need to level shift the ports and you need to have an external power source. Now I've broken out a few pins that are level shifted, 3 normal pins, and the SPI bus is shifted as well. So now I can use the SPI bus on board, obviously, for my card reader, and I can add 3 extra 3.3 volt SPI devices without using any extra hardware. So you can see I can run this display directly from my board without running it from 3.3. This is still a 5-volt board, and I can daisy chain this. So that works quite well. Now to show you the card reader, which is kind of cool, so you can see here, it's on the bottom. It's really flat, so even with the pins, it won't touch the breadboard, so there's a little bit of space left. Now to show you that it actually worked, I put on a little file called demo.txt, and it's got 2 words in it, and if I connect it and reset the board, it will read it and add it to the display. There you go, SD card read. So it's actually working. To prove it, I disconnect it. Another feature, by the way, if you put in the card, it lights up blue. This is not done in software, it's done in hardware, so it doesn't influence your code. As you can see, it switches off. When the card is in, it's on. It's very handy. Now let me reset it again, and the text will be gone because there's no SD card. As you can see, gone. So that works just fine. I've got a very low profile ISP header, so if you want to use it, you can use pogo pins or normal pins to program it. And that's basically it. This particular board comes in Dark Photons black because, well, I just like it. And this is the first prototype, so I'm probably going to make a few silk screen changes and maybe 1 or 2 design changes, but I'm pretty happy with the way it is now. And as you can see, it works just like a normal Arduino Uno with the extra features of USB-C, extra EEPROM, NeoPixel, and SD card reader, and level shifted ports right out of the bed, right out of the box. So you can just use it as is. Now I'm probably gonna put these up for sale. I'm not sure how to do it yet because it takes me forever to build these. And as you can see, this board needed some rework because I'm using a QFN factor, form factor chip, and they are very easy to create solder bridges here. And yeah, it's a pain in the ass to manually build. But nevertheless, if you're interested, leave me a comment and we'll take it from there. So that's it for today, and I'll go back and try and fix some other issues on this board and design the final version and show you all its capabilities when that's done. All right, until then, I'll see you later.